Combining like terms. I believe this might be the last notes, maybe, for this unit. I'm thinking, right? So we have got to put some things together, like combining like terms here, okay? And I have lots of highlighters today, okay? So if you have your own at home, or we can share some in class, guys, we need the highlighters. We need them. We need them like we need to brush our teeth every day, you know, they kind of go one on one, right? So let's talk about our objectives that we're going to be looking at. We may not master them today, but they are going to be a hardcore focus, okay? So identifying the parts of an expression, okay? Applying properties of operations to generate equivalent expressions. Huh? Yeah, we'll get there. We'll get there. That will not be mastered today. Simplifying an expression by combining like terms. Okay, so this is really an introduction, and we're going to keep practicing as we go. So let's get this started. So, term. A term is separated by operation symbols. Okay, so we're going to circle those. So 6x is a term because 6 and my variable x are kind of glued together. That's a term. 5y is a term. X is a term. 8 is a term. Okay? Like terms have the same characteristics. Okay? So this is where my highlighters are coming in. So what I do is I start with the first term, 6x. Okay? And 6x has a coefficient of 6 and a variable of x. So I'm going to highlight that. This is the very first term. It gets its own color. Okay? Now I'm going to look for another term that has the variable x. Okay? And I see x all by itself. So it is still a like term. Okay? I don't have any more with x. I'm going to get rid of that. Now I'm going to go to my next term, 5y. And I am going to highlight 5y. Do I have any other terms that have the variable y? The answer is no. And then, all by itself, I have the constant 8. Okay? So as you can see, I have I have 4 different terms, but 2 are alike, and I have 2 other ones that are different from them. Constant is a number all by itself. All right? So this time, I'm going to circle my constant. So it's a number. And the constant also does not have a variable attached. So the only constant is 8. Okay? Coefficient is a number in front of the variable. Okay? So I'm going to do this with the yellow. The coefficient. So watch the first term. I'm just going to highlight the number 6 because the coefficient is the number, not the variable. 5 is a coefficient. Okay? And that's it. X is a variable by itself. 8 is a constant. So if it's a number in front of a variable, that's a coefficient. A variable is a letter representing an unknown value. Okay? That's a variable. So I'm going to use a different color. So my variables are the letters. No, not the coefficient, just the letter by itself. Okay? That's your variable. Okay. Operation would be addition, subtraction, multiplication, and we're using a dot right now because now we have that variable x, and division. Okay, so I'm going to use orange this time. So my operation would be this. That's my operation. Addition, addition, and addition. Okay? Oops. Now, the expression is a combination of terms and operations. Okay? So in this case, this entire thing is an expression, the whole thing. Okay? So, for this example right here, it says to circle/color and link each set of the like terms. So we are not combining. We're going to color code them. So again, I start with in my first one, I have 4x plus 10y plus 6x plus y plus 2. So take a color, highlight the very first term, okay? Do not highlight operation symbols, just the term. So 4x. I'm looking for another term that has a variable x attached to it, and that would be 6x. So these are going to be the same color, okay? And do I see any more? No. Put that one away. Get your blue. I'm going to highlight 10y now, okay? Do I have another term with the variable y? Yes, I do, right there. All right. And then I have my constant 2 all by itself, okay? So I just grouped them, okay? 4x and 6x, 10y and y, and then my constant 2. All right? Let's look at the next one. I have m, so the variable m. Do I have any more? Yep, another m and another m. Okay, those are all the same. I did not highlight 2n because m and n are not the same variable. But I can highlight 2n, okay? Because we're going to simplify and combine in the next step. I'm just showing you this breakdown first of how we're going to color code. 9x. So I have 9x, and then do I have any more with x? I have x, and then I have 2x, okay? There are no other terms that have the variable x, so we're good. The next thing I'm going to highlight is my constant 7, because it's a number all by itself. Do I have another constant? Yes, I have 13. That's it. Okay? So now we are going to simplify each expression. So I have my I do. I'm going to start with 5r plus 6r. So I'm going to highlight my first term, which is 5r. And I look for another term that has a variable r, which I have 6r. So if I have 5 r's and I have 6 r's, well, what you're going to do is leave the variable alone. Add your coefficient, 5 and 6. 5 plus 6 is 11. And I bring down my variable r, because now I have 11 r's. Now this is simplified because I don't have a value for r, so I can't multiply. I can't completely solve it. Look at our redo. I have 3x. That's my first term. Okay. Then do I have any more? I have 5x. Okay. And then I have 2y. Do I have any more with y's? No. Okay, so that color is gone. And then I have my constant 4. Okay. Now I'm going to combine. So starting with my 3x, I see that I have another like term, 5x, and I'm adding. You see my adding? So 3 plus 5 is 8x. Then go plus your next term, which would be 2y. Okay, so we'll talk more about the order things going, but please note how I'm doing it. I'm going x first, then y, because x comes first in the alphabet. Then I have 2y, but I have no other like terms, so 2y comes down. Then I have my constant 4 last, and that's as much as you can simplify. All All right, look at this one. 10m. I have 10m. Another term with m is just m by itself. I don't have any more, so I'm putting this away. My next one is 3n. Okay, do I have any more with n? I do have 5n. In this case, we're adding everything. Ooh, you hear that thunder out there? So m comes first in my alphabet before n, so I'm going to add my m's. I have 10 m's and one more. Now, this m all by itself represents 1, okay? But we don't put the number 1 as a coefficient ever. So if you see a variable all by itself, like the m, that means 1. So 10 plus 1 more is 11m, plus I have 3 n's and 5 n's. 3 plus 5 is 8n. That's it. You're going to do the you-dos on your own. Now, up here, simplify each expression. This time we are applying distributive property. So I have 4 times, parentheses, 4 times 4r plus 4 times 3t plus 8. So draw your arrow. Oh, yeah. Nope. I lied. Nope. Don't do this. Just do what I'm doing. First, we're going to distribute first. So 4 times 4 is 16. Keep your r plus, because we did this on properties, the last notes. And then 4 times 3t, so 4 times 3 is 12. Carry your t plus 8. Okay? Now, to check and see if I can simplify even more, I'm gonna highlight my terms and see if I have any like terms. So I have 16r. Okay. I have no other r's. I have 12t. That's the only one I have. And then I have 8 constant all by itself. So these are all different terms. I can do nothing else. So I've checked myself. Now I have 2x times 5 plus 1 plus 7. So let's distribute that 2x. 2 times 5 is 10. 10, bring your x with you. Bring down your symbol from your parentheses. Plus 2x times 1 would be 2 times 1 is 2. Bring down your x plus 7x. Okay? Take your marker. Let's highlight. Okay, so I have a 10x, I have a 2x, and I have a 7x. So these are all like terms. So again, imagine we're just going to add our coefficients. 10 plus 2 is 7. Nope. 10 plus 2 is 12. Plus 7 more is 19. And don't forget your x. Okay? I'll rewrite this one. Sorry. There you go. And you have 4 you-dos to do on your own if you were not here. So let's talk about these I-dos and you-dos or problems. Okay, so Amy ran R times in January, quadruple that amount in February. So we're multiplying that by 4. And 6 times the original amount in March. So times 6, okay? Write an expression in simplest form to represent the total number of times she ran. So she ran R in January, and we're writing the total number, so we're adding, okay? Plus 4 times the January time, so 4 times R, because she's running this many times. 4 times this many, okay? 6 times this many, plus 6R. So I'm going to highlight my like terms. Starting with R by itself, it's my variable R. Do I have any other terms with a variable R? Yes, I have 4R and I have 6R, okay? So 1R plus 4 plus 6 is 11R. So 11 times R, 11R, okay? Now again, this is simplified because we don't know how many times she ran in January, so we have no idea. Look at our we do. Jared blinked B times in the first hour. Triple that amount is times 3. In the second hour, and 345 times in the third hour. Write an expression in simplest form to represent the total number of times he blinked. Okay, so hear me out. Jared blinked B times. So B in the first hour plus 3 times that amount. So 3 times B. But look at this. And then he blinked 345 times. So they're not even making you guess. They're saying he blinked 345 times. That's a constant. Okay. Now we got to combine this, okay? Let's see how we can combine it. So starting with my first term, B, whoopsies, the variable B. Do I have another term with the variable B? I do. I have 3B. Do I have any more? No. And remember, 345 does not have a variable B. It's a constant. So he's alone. He's alone. He cannot be combined. All right. So B, 1B plus 3 more is 4 B's plus 345. And there it is. Well, you do on your own.